Hello everyone. In this video, I want to provide an overview of JSON and how to start working with it in Python. What I have open on my screen here is VS Code with an empty main.py. In this main.py, I am going to take some brief notes on JSON, and then we're going to see some examples of how to work with it in Python. So let's start by defining JSON. This is an acronym that stands for JavaScript Object Notation. And even though JavaScript is in the name, JSON is not specific to JavaScript. JavaScript is a programming language like Python, but JSON is not for only working with the JavaScript programming language. In fact, it is the most common format of data for passing data around on the web. It's increasingly used just to store data in files, just like you would use a CSV file to store data in a comma separated value format. You could use JSON to store data in what's called a key value format. So what is JSON? It is a data format using key value pairs. You might have heard of key value pairs before. For example, if you've worked with Python, then you've worked with a dictionary. A Python dictionary is a collection of key value pairs. The syntax for a Python dictionary is actually really similar to JSON. So if you've worked with those Python dictionaries before, you're well equipped to start working with JSON. All right, so let's start with a JSON key in a key value pair. So the key, aka the name, is a string. For example, ID. This could be a key that is used to index into the JSON object to get a value. So now let's talk about value. So a value could be one of many different types. For example, if a key of ID maps to, say, a numeric ID like 1, 2, 3, 4, then it could map to a number. This doesn't have to be an integer, it could be a float as well. A key string could map to a value string as well. So I'll put string here, e.g. 1, 2, 3, 4, maybe a z, something like this. We could also have a key map to an array value. So with arrays in JSON, we use hard brackets much like how we use hard brackets for lists in Python. So maybe I have the values 1, 2, 3, 4 in an array. We could also have a Boolean, for example, true or false. And then lastly, we could have a JSON object. And I'll put e.g. here, nested or nesting. So we can have a JSON object with a key that maps to a nested JSON object. Think about this like a Python dictionary and a Python dictionary. So let's pull this all together and just see an example JSON object. I could have ID, colon is used for mapping, just like with a Python dictionary. Let's say 1, 2, 3, 4. Okay, this is a valid JSON object. Let's do one more. Perhaps I have an ID mapping to a JSON object where maybe there's name, Jane, age, 20, something like this. So ID is still the key, and now the value is a JSON object, which itself has two keys, name and age. All right, I've got a few example JSON objects for us to start working with. I've chosen these two objects because the first one is going to be really easy to work with, but it is actually going to break this mold a little bit, and the root JSON type is actually going to be an array. And then the second example I have is a little larger example where we'll have some nesting, and so we'll need to drill down to get some of the values out. So if you want to follow along, at this URL at the top here, I have two files. The first one's called activegraphdata.json. So what this data represents is 5 minutes of data from a device called an ActiGraph. It's a wearable device much like a Fitbit or Apple Watch or a Garmin watch or something like this, where it records a timestamp, the number of calories burned, heart rate, lux, steps, where XYZ acceleration and XYZ axis counts. Everything within this JSON object right here represents 1 minute of data. So you can see that the root JSON object here is not a dictionary. It's not key value mappings. It's instead an array. So this is an array that has 1 JSON object, 2, 3, 4, and 5. So this is an array with 5 JSON objects in it. Okay, this is an array, not a JSON object, meaning key value mapping. So if I wanted to access this first JSON object, then I would simply use index 0. So here's what I'm going to do. I'm going to copy this whole thing to my clipboard, and then I'm going to head back over to Python, and I'm going to store this in a string called JSON array string. Okay, so the whole thing is just stored as one big string. Now, we're going to start working with this data. We're going to do it 2 ways. The first way, we're going to use the standard JSON library, and then the second way is we're going to use the Pandas library. So right at the top, let's import both of these. So let's create a JSON object, which will be a Python list in this case, because the outermost object type in this JSON data is a list. Okay, I know that because the opening symbol is a hard bracket, not a curly bracket. Okay, so I'm going to do JSON array is assigned JSON.loads. You'll see there are 2 options for load and loads. So load is for reading JSON data from a file object. Loads is for reading JSON data from a string. Okay, so let's print out the type of JSON array. Okay, it is a list. Okay, so the JSON library in Python is going to load this JSON array into a list. So let's take a look at it. So here it is. All right, let's try walking through each array object in the JSON array. I'm going to print out the array object, and then I'm going to print out some stars just so it's really easy to tell the difference between each one of my objects in the array. Okay, so here are all 5 minutes of data. So the first minute JSON object, the second minute JSON object, the third minute JSON object, the fourth minute JSON object, and the 5th minute JSON object. So for each JSON object, I could use a key such as timestamp UTC or HR or axis Z counts to grab values like this timestamp 0.0 or 55. So let's try it. Let's grab the timestamp in the subject's time zone, TZ. So 2023. So this would be March 23rd, 2020 at, 2028. So 8:28 p.m. We'll see what was the calories burned in this minute on this date. So I'm going to do array object sub timestamp subject TZ. Oops. Case sensitive here. All right. So now I'm able to get the value for subject timestamp TZ for each one of the JSON objects in the JSON array, which is being stored as a Python list. All right. Now let's print out the array objects calories value. Okay, so now at each minute, we have the value for calories. All right, the last thing that I want to do before we move on to a slight variation of this example is simply to print out the type of the array object. So make a prediction about what you think it's going to be. So it looks like array object refers to a dictionary object, which makes sense if we look at our data again. Each one of these elements in the JSON array is a JSON object, which can be represented as a dictionary in Python, which is a collection of key value pairs. So working with JSON and Python is pretty straightforward and pretty fun because JSON arrays directly map to Python lists and JSON objects directly map to Python dictionaries. Keys directly map to Python strings, and then the values can be mapped to a data type in Python, right? Like here's a string, here's a float, here's null, here's a Boolean, here's an integer. All right, let's do the same example, but let's read the active graph data from a file. So what I'm going to do is copy all of this data again, but I'm going to put it into a file instead of into a string. That way we can see an example of how we can use the JSON library to load JSON data from a file into a Python object, such as a list in this case, or if the root object is truly a JSON object, into a dictionary. So I'm going to do activegraphdata.json, paste my values, save this file, and now we're going to open this file. So if you put this file in the same directory as your main.py, then you'll be able to just use its file name as a relative path for opening it. With this file open for reading, that's what the R file mode is here, now I can pass this into json.load in order to load it from the file, load the data from the file. So I'm really going to do this whole example again, but instead of json.loads, I'm going to use json.load, and I'm going to pass in file. And now the example works the exact same way, but we're loading our data from disk, from a file, activegraphdata.json, instead of from a variable, a string variable in our Python program. So here's how you can read your data that's in a JSON file in using Python and its JSON library. All right, as I said a few minutes ago, we're going to do one more demo of how to work with data using Python. We did JSON, now it's time for Pandas. So I can actually read this data in directly into a Pandas data frame in a one-liner. All right, so let's have JSON df for data frame is assigned pd.read. You can look at all these different file types that you can read data in from with Pandas. So lots of fun things you can work with. Right here, read JSON. We're going to pass in a path to our file of JSON format that we want to read into a Pandas data frame. So let's do the same thing, activegraphdata.json. Okay, let's just comment this all out for now. And then we'll print out our JSON data frame. So here's our data frame, which is essentially a really powerful 2D list or 2D array, where for our columns, we can actually use nice string label-based indexing. So Pandas is pretty smart. It figured out that we've got an array where each element represents a row, and then the keys in each element, which is a JSON object, represents our column. So here they all are here. So now we can use standard Pandas indexing to say grab all of the timestamps, grab all the calories, or if we only want, say, the first timestamp, we could do that as well. All right, let's do another example. Okay, we won't introduce any new Python programming techniques with our JSON or our Pandas libraries. But we'll do another example, but this time with different data, because this data we work with right here was in a pretty nice format, especially for reading it into a Pandas data frame. Okay, our outermost type was an array. Now let's see an example where our outermost type is a JSON object, meaning it's a curly bracket instead of a hard bracket. So if you go back to this URL right here, where I've got a repo that's public, you can go to Files, and I've got Thor iTunes search.json. Okay, so if you look at this data right here, like I said, the outermost character, right, representing our outermost JSON objects type is a curly bracket, which means this is a JSON object. It is not an array of JSON objects. Okay, so this one is slightly different. Let me briefly explain where I got this data from. So I went to the iTunes Search API, and under the left side panel, there's constructive search, and this is where you can learn how you can search the iTunes database using the iTunes Search API for different media. So I constructed a search query. In fact, I'll show it here so you can reproduce it in case for some reason you can't access my example data. Okay, itunes.apple.com/search, ? And then we have our search term. I simply did Thor because it returned 6 results when I specified that the media type was movie, which was a nice, small, manageable size to work with, but you can put whatever search term you want in here. Just be wary of anything with spaces. If you want to put spaces in, you have to format that correctly as a URL. All right, and then ampersand to separate our key value pairs. This is in our search box here. And then media type is movie. Okay, so this is going to prompt you to save a file called one.txt. I'm going to save this as Thor iTunes search.json in my JSON fun folder where I've got my main.py and my actigraph data.json. All right, here it is. It's actually kind of hard to read. I recommend if you're ever working with JSON and it's not nicely indented like this one was, that you use a pretty printer in order to make it nicely indented, because it'll be much easier for your eyes to see what you're looking for if there's indentation levels to it. So I'm going to do that real quick. I'm going to select all of this, copy it, and then go to Google and do a search for JSON pretty printer. The first one that pops up is a pretty good one, jsonformatter.org. On the left side, you can you can paste unformatted JSON, and then click Make Pretty, and then it's going to make it pretty with nice indentation levels. So this is much easier to read than this left side. All right, so let's take a look at this and see what we got. So we've got a JSON object with a key result count, which maps to 6. So it's telling us there are 6 results for our search. It's got a key called results that maps to a JSON array. I know this is a JSON array because of the hard bracket here. Okay, now within this hard bracket, okay, I'm going to enter into this value. I have 6 JSON objects, 6 elements where each element is of type JSON object. So let's highlight the first one so we can see it clearly. Okay, so all of these lines right here represents one result for a Thor movie. Okay, so let's just look here and see. Okay, we've got a track ID. All right, track name Thor. So, okay, this is representing the first Thor movie. Okay, we've got a preview URL, some artwork URLs. We've got prices. We've got a release date. It came out May 6, 2011. We've got track time in millis. How many milliseconds does the movie run for? We've got the advisory rating. It's PG-13. The genre, action, adventure, short description, long description, all sorts of fun things in here. Okay, so these are all keys that we can use to grab values about each one of our Thor movies. So let's try it out. Okay, let's say I try to read this in using Pandas. Okay, I want to show this to you because Pandas is awesome, but it doesn't always give you exactly what you want. It does its best. So here I print out Thor DF, and I'm expecting to see quite a few columns, right? Because, wrapper type, track, all the URLs, I expect those to be in nice columns. But instead, I just get 6 rows where each row only has 2 columns, right? Result count and results. So unfortunately, the whole JSON object was not correctly parsed into its columns. This happens, and this is why I showed you how to use the JSON library, because if this happens, then you can use the JSON library to do the parsing yourself. So let's do that. So I'll make a little note here. Doesn't give us correct columns. All right, so let's do the parsing ourselves using the JSON library. So let's have JSON obj, JSON object is assign JSON.load. Okay, recall I want load, not loads, because I'm going to be reading from a file. So I'm going to open that file. It's got that long name I gave it. Probably should have given it a shorter name. Thor iTunes _search.json. Open it for reading, and then let's print out that JSON object. All right, so there it is. It's pretty huge, right? Lots of scrolling, oh my. But fear not, we're going to go back to our pretty printer to help us parse through this, and we'll take it one step at a time. So let's say we want to get all of the track names, and let's do track names and track time millis, how long the movies run, okay? So what we're going to do is we're going to use the key results to get the value, which is this whole huge 6-item array. Okay, so what I did is I identified what I wanted and I worked my way out. Okay, so I know I want to get the track name and I want to get the track time millis. Okay, that's going to be in a JSON object, which is an element in a JSON array, which is the value for the results key. So let's do it. So let's do results array is JSON object, which is a dictionary, index using results, and then we'll do for result object in results array. Let's print out the result object. Let's grab the track name while we're at it, and then we'll print out some stars to separate our different movie results. Okay. So with just this few lines of Python code, I'm able to grab out the movie names for all 6 results. So we've got Thor, Ragnarok, Dark World, Tales of Asgard, I Am Thor, and Valhalla, The Legend of Thor. Okay, so now a quick task to try. Pause the video, grab the milliseconds for the running time, and convert it to minutes. Then check your work. Okay, grab one of these movies, see what your output prints for the number of minutes of its running time, and then check that against Google and see if it's correct, see if it lines up correctly. If so, we've got a pretty good JSON parser working here, working with some real data that we grabbed from iTunes. All right, so I'm gonna do this. Let's do track name. Let's do track time in milliseconds. Okay, so I've got to figure out what is that key. The key is track time millis. And then I'm going to convert this to track time in minutes. Okay, so there are 1,000 milliseconds in a single second, and there are 60 seconds in a minute. So now I'm going to print out track name and a little mapping symbol here, and then track time in minutes. Okay, so here they are. Looks pretty reasonable. 60 minutes in an hour. So let's test one of these. Let's do Thor Ragnarok. So this is 130, almost 131 minutes of running time. Let's see what Google says. So Google says that Thor Ragnarok's running time is 2 hours, which would be 120 minutes, plus 10 minutes is 130 minutes. So definitely lining up with our little calculations here that we grabbed from the iTunes Search API. Well, we covered a lot in this video. Just to recap, JSON is a really popular format for storing data, structuring data. We saw this with two examples working with the active graph data where the root JSON object wasn't actually a JSON object, it was a JSON array. And then we saw this again with the iTunes search results, searching for Thor movies, where the root JSON object was in fact a JSON object. So we saw those two examples. The first one worked really well when we were loading it up using Pandas data frame. The second one didn't work so well, but fear not, we learned how to parse JSON data using the JSON library ourselves. Really what we're working with is Python dictionaries, Python lists, and Python strings. So I hope you learned a lot in this video, and I hope you're intrigued by what we were doing with the API over here. If you are, tune in to some of my next videos on how to start working with APIs in Python. That's it. Thanks for watching.